In this video, we're going to talk about LitServe, a lightning-fast serving engine for various AI models. So this video will be broken down into three main sections. We're going to talk about what it is, why is it better than vLLMs, or is it actually better than vLLMs? We're going to talk about some differences between the vLLMs and other deployment methods. And we're going to talk about how to use it using a Google Colab example, which I'm going to share with you guys, obviously. And we're going to talk about different models. And I'm going to come to that way more at the end of this video. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools. So please feel free to subscribe. Now let's talk about the benefits of LitServe. LitServe is in essence a general framework where you can deploy any machine learning or deep learning models. It's fast and flexible, and you can deploy with any infrastructure. This can be AWS, GCP, or your own home server. And the main idea is that once you have this your own server, your own LitServe server with this LitServe package, you can deploy it where you can use a endpoint to call and go back and forth with a model. Now, which models can you deploy? You can deploy pretty much anything you can think of as long as you can wrap it with this LitServe wrapper package. You can use a scikit-learn model, an XGBoost model. You can deploy a multimodal models like Qwen2VL, which I recently covered in my channel, Phi 3.5 Vision, Bird, Hugging Face, of course, and many other models you can think of, even XGBoost and Random Forest. Now, what is it? So the main idea is that it's a way to streamline model serving, allowing easy transition from training with PyTorch to deployment. You can also serve models in a scalable fashion. Of course, very, very similar to vLLMs, but we're going to go more into that very, very soon. And we have production-ready tools for monitoring, logging, and managing models efficiently in a production setting. Now, personally, I haven't really touched upon or worked with monitoring and logging that much. Well, logging, yes, but not much with monitoring, but you can still do that with this package. Now, what is the difference between the vLLMs and LitServe? Now, I'm sure a lot of people who watch my videos probably know what vLLMs are. If you guys didn't, it's a way to deploy large language models in a very efficient manner. And if we focus on 4 different areas, we have purpose, focus, technology, and use cases. When we look at vLLMs, we can see that vLLMs is usually made for serving LLMs efficiently with low latency and high throughput. That's kind of their whole thing. LitServe, on the other hand, is morely focused on scalable and production level environment. It's more like the Swiss knife of deployment various machine learning models, including deep learning. And the focus of vLLMs is inference optimization, memory efficiency, and model parallelism, like distributed inferencing and KV cache, page retention, and all that. That's kind of their expertise, if you may. LitServe, on the other hand, is more like on the entire development cycle, from training, inference, monitoring, and even evaluation of various models. So the whole package. On the other hand, technology-wise, vLLMs is purely focused on LLMs and inferencing and making it faster, whereas PyTorch Lightning is more for like scalable deployment. How can you scalably deploy models, distribute it properly, and so forth, with any hardware, of course. And this goes with both of them. The users, on the other hand, now I've spoken with a lot of companies and they kind of use vLLMs for most of the LLM deployment, and it's done for their production environments. And LitServe can do the same thing, but it can also be for research tool as well. And also LitServe, you can actually use vLLMs, where you can use vLLMs as the engine inside of the LitServe wrapper, where you can actually deploy a LLM using vLLMs for faster, higher throughput and scalable production scenarios. So we're going to go more into that once I dive inside of the code. By the way, I just want to quickly mention that in the description, there is a link for AI consulting. This is a one-on-one meeting with me where you can book a call discussing your personal projects, or if you're a company trying to build a proof of concept, you can just grab a time over here and we can talk about it. I can help with ideation and planning, feasibility assessment, and at the end of the call, we can get a report detailing the different steps you could potentially take to improve or make your system. So please feel free to check it out. Okay, now we're going to see LitServe in action. So first thing that you guys will have to do is you have to install Fast API and UVCone, LitServe, and LitGPT. And then you may also need to download Hugging Face Hub CLI to be able to download the model that you want to serve if you have stored it in the Hugging Face Hub. Now, these are the packages you will need to install. And then we're going to download and deploy or serve Llama 3.1 model and then make the predictions. And at the end, our goal will be to make a server that is hosted in this specific port where we are able to write a prompt and we're supposed to get a output. Now, let's make that happen. The first thing that we will do is we are going to download our Meta Llama 3.1 model. This can be any model of your choice. Now, what I found is this actually downloads from the Hugging Face Hub, so that if you have a fine-tuned model or any other new model that you want to serve, you can just copy the Hugging Face name of that model and just paste it over here. Now we are using a Google Colab, as you probably notice over here. That is because it's quite easy for me to use and show you guys how to use it. And whenever I share this Colab notebook, you can just run all the different commands and be able to play with it. But typically you would host this in a server. This can be like an AWS GCP cloud platform server or your own home server. Now the model has been downloaded into our local directory, which is over here. We can see the checkpoints, Meta Llama 3, and this will be used to do our inferences when we deploy or serve the model. Now, what we're going to do is we are going to make a file called server.py. This is done to serve the server.py for our endpoint. So typically you will run it like this, like Python server.py. You just run it and the model will, or the package will serve the models that you have in that file. Now, here's what I mean. So let's make our file. So over here, because we're writing it in Colab, we can write file server.py, and then we are going to import LitGPT because we are using LitGPT to download and serve our model. And then we're going to import LitServe as ls. And now we can define our class. So we're going to write a simple lit API. We're going to write def or def setup. We have self and device. This device is the GPU device. And then you can write self.llm, litgpt.llm.load, where you load the model that we have downloaded over here. And this can be any different type of model you want. This can be like a scikit-learn model or any other model of your choice. Again, I'm going to show you guys more examples of how to use different other models very, very soon. We're going to define another function called decode request that's going to take our request and decode it. We're going to predict or define the predict function. So we're going to return self.llm.generate the prompt, and you can define the max tokens. Again, you can customize it exactly however you want it to. Now, as far as I understand, whenever you call the endpoint that we do over here, so the endpoint that we're hosting /predict, as far as I understand, you're calling this function over here, and then you get an output. We're going to encode the response, another boilerplate code. And now for the entire class, we're going to define a main function to serve our model. So API, simple lit API, server API, and port. What's nice is it's actually built on top of Fast API and PyTorch. So something if you guys are wondering. And now what we do is we have to write Python server.py. Now here's one thing. Because we're running this on a Google Colab notebook, when you execute this is going to keep on running this command, and we cannot really do anything else. So we have to kind of just run this in the background. So what we will have to do is we have to run or write no-hop Python server.py, and we're going to write and then we're just going to write print hi. So what this will do when we execute this, it's going to run this, and while this is running, it can now execute the next cells and however many cells you want, which is a nifty trick I learned recently. So we're going to run no-hop Python server.py and run. And as you can see, when we have created this file, this got created on our content directory, which looks exactly the same as the things we've defined over here. And when we refresh this, we can see nohop.out, where we can see the logs of the models that we have deployed. So as we can see, waiting for application startup complete. So now it's being served at this specific endpoint. Now we can start asking questions. So here I made a curl request at this endpoint and wrote, what is the meaning of life? So hopefully we can get some nice answer. So over here, the output says, what a profound question. The meaning of life is a subject, blah, 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 blah. As you can see, from this endpoint that we have deployed our model with, now we can ask questions about it and get an answer. Now, of course, you would do this in a server of your own. This can be an AWS server, a GCP server, or your own home server. And now you can deploy a model with relative ease and no effort. Now, what about if you want to serve different types of models at the same time, or using the same endpoints but having different models being served in the same endpoint? Now, here's an example with a provider which I found to be very, very interesting. So let's say you have a server. So let's say you have a server.py Python file. So in the setup that we've defined over here, we have only loaded one model over here, but you can load many different types of models. You can do settings.llm, you pass in an Llama model, you can have an embeddings model in the same place, you can have a vector store in the same place, documents, and you can even load scikit-learn model over here as well. You can load a random forest classifier. Because as we know, AI is not just about LLMs, it's about many different things. It can be about recommender systems, it's about random forest, it's about XGBoost, and many different other factors that you can use when deploying a model. So it is highly, highly flexible, and which is quite different to what you would typically have in a vLLM. Just write a prompt and that's about it. But with a LitServe API, you can have a lot of flexibility for your end deployment Alright guys, there you guys have it. This is LitServe, a way to deploy many different types of models, scale it, and do many different interesting things with relative or minimal effort. I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. Alright guys, have a nice day. Bye bye.